In today's video, I'll be introducing you to a parallel trickle flow reactor system, which has been particularly designed for handling heavy feedstocks or highly viscous liquids, primarily derived from pyrolysis oils, from bio feedstocks, or from plastics pyrolysis. At the upstream side here, what you have is basically the gas dosing section where we have our central gas components that can be connected here, everything from synthesis gas to H2S, for pre-sulfiding if we have sulfurous components that we want to remove via HDS. And we have the liquid dosing section here in the bottom. We're using the heated Vindom syringe pump system here, which can give us extremely low flow rates and very high pressures with no pulsation, which is very important because we're working with a capillary flow distribution system for splitting these viscous components, which I'll show you on the back side of this unit. The gases are then controlled, dosed to each reactor independently, so we don't use the capillary flow split for gases. We're working with independent mass flow controllers for the gas dosing for each and every reactor, allowing you to operate them at different space velocities, but also giving very high precision. We then move into the reactor section here, which is enclosed in a convection oven. This is a custom convection oven from ILS. Very important because we're working with a lot of very fine tubing on the front end here, and we don't want to have to work with heat tracing everywhere. As you see at the top here, we have the ability to monitor this oven continuously for any flammables or hydrogen which are potentially lost due to leakages. Very important for safety reasons. When dimensioning the trickle flow reactors, ILS takes great care to ensure that the hydrodynamics required to achieve high conversion levels are taken into account. In this case, particularly looking at long, thin reactors to ensure that we have true plug flow. The isothermal lengths of these reactors are all 40 centimeters in this case, which allows us to achieve very, very deep conversion levels, even for reactions like HDS, which need nearly 100% conversion, which we can achieve because of the lack of any axial backmixing in the system. Reasons. And in order to be able to remove the reactors from the top here without having to go excessively high with the oven, you simply remove this top portion here, and then you have a finger-tight closure, which allows you to remove each of these reactors independently. I'll show you on the back side of this unit what the downstream looks like, and see you there in a second. This is the downstream section of the reactors. What you'll see is we have two blocks containing 4 reactors in each block. And what we have the ability to do is to run all of the gas-liquid phase components into compact gas-liquid separators, which are in a robot, which is heated or cooled depending on the product being formed. So if we're working with, for example, naphtha-like components, we want to cool it to collect as much liquid as possible. If we have, say, a Fischer-Tropsch paraffin, we need to heat it to be able to keep everything in the liquid phase. And again, everything here has been kept in the reactor oven to make sure we don't have any cold spots. We also have this modular system here for holding our capillaries. We work with compact metal or silica capillaries for splitting these liquids effectively from reactor to reactor. And the advantage of working with this modular system is that we can deliver the clients pre-calibrated capillaries, which they can just click in or click out as they need, making it much more user-friendly. So a very nice system which allows you to access all components from the slop pot all the way down to all of the liquid samplers without having to remove any heat traces. The robot is an XYZ robot, which is actuated up and down to be able to pierce the septum seals of the glass vials which collect the samples. One advantage of working with glass vials is you don't have to do much cleaning. You can simply remove them and then put them into an offline GC for direct sampling, or an offline liquid handler if you want to do dilution of the product offline. Again, it can be heated and cooled, which is relevant depending on the product being formed, so that we can keep it in the liquid phase and collect as much product as possible for as tight a mass balance as possible. If you'd like to learn more about how ILS can help you with your trickle flow reactor testing, please feel free to contact us, and thank you for listening.